Good afternoon, everybody. Kyle Cecil here at the University of Illinois Extension. I'm going to be your moderator here today, and we're going to get going really quickly into our session here today with Jeff Kindhart. We're going to do one more thing here, and I'm going to turn it over to Jeff. Above the chat box on the right-hand side is an A, B, and C. And what we'd like to know is if you're currently using a high tunnel, click A. If you're B would be if you're currently but going to expand, and C is if you've never used a high tunnel, grown in a high tunnel. So A is you're currently using it, B is you're currently using it and going to expand, and C is you never have. And I'm going to publish those here so everybody can see what that looks like. Okay, so Jeff, it looks like we've got quite a few new people here, so we can keep that in mind. And I got to write down a quick number here before I forget, 7 and 20. Okay, so with that, we're actually going to, I'm going to hand it over to Jeff Kindhart, and Jeff's going to lead us through this afternoon and talk about managing crop rotations in high tunnel. So I'm going to give you the mic, Jeff.
We've got a lot of material to cover today, and because of that, we're going to move fairly fast. I'm a bit surprised that the number of people who are taking this have not grown a tunnel before. There's lots to see responses. No problem. We'll try to make that worthwhile for you. With that, today, I guess I should do a little bit to introduce myself. My name is Jeff Kindhart. I'm a horticulturist with the Crop Science Department with the University of Illinois. I work at an ag experiment station located in extreme southern Illinois, about 30 miles north of Paducah, Kentucky. We have been growing crops in high tunnels here for 3 years at this point, although I've worked with growers for, well, better than 10 years that have been using high tunnels down at this end of the state. So today's topic that was posed to me was managing crop rotation in high tunnels, and so here we go. For those of you that are new, high tunnels are a lot like greenhouses, and really the only thing that differentiates a high tunnel from a greenhouse is that greenhouses have some source of heat other than just natural sunlight. High tunnels only rely on solar radiation for their heating source. At the point where you add, it doesn't matter if it's a wood burner or a kerosene heater, at the point when you put any heat in the structure, it is no longer a high tunnel but is now a greenhouse. And most of them look like this is one of ours here at the station that you're seeing in this picture. They're long structures, and typically the side walls, as you can see, go up and down for affording ventilation. Uh-oh, that clicked really quick, my bad. There are some growers, but this is the exception, not the rule in the state of Illinois, that have tunnels that rather than being located in one single position, they are movable. As you can see in this slide right here, in that top picture you can look, they have 3 different locations which they can set that high tunnel. In some cases it moves along tracks like you see in the bottom right picture. In other cases the houses don't have tracks, but you simply jack up along each of the 2 side walls and you place tires on it, roll it to the new location, and then reset it back down and remove the tires from it. So we've kind of talked about high tunnels, so anyway, it's rotation in high tunnels, so now we need to talk for a brief bit about rotation. Why do we normally consider crop rotation good? And by crop rotation we mean not growing the same thing time after time in the same location. Crop rotation is normally associated with increased plant performance, and that's for a number of reasons, but that includes a reduction in the amount of disease, a reduction in nematode and insect pest. In some cases we may also reduce weed pressure, particularly if as part of our cover cropping operation or as part of our crop rotation we're including cover crops. Specifically mustards tend to reduce weed populations, but there are some others like rye which may also suppress weed growth. Another thing that you'll see touted as a benefit for crop rotation, some crops use an awful lot of one particular nutrient and not so much of another, and by changing different crops and deciding which ones feed heavily on which elements, and we look at our soil test, and crop rotation may help us to get soil nutrients back in a more balanced level than what they were if we have developed some sort of problem with nutritional balance in our soils. Unfortunately, crop rotation also has some potential pitfalls, and we should start this by saying that rotation is one of those things that is often not practiced in high tunnels, and we'll talk about strategies to get around that, but or even the value of rotation in high tunnels. But there are some problems associated with rotation, and one of the biggest ones, if you'll read through that slide, it basically breaks it down into a couple of different things. One is that when you rotate, you have to grow obviously more than one crop, and so you are not spending all of your time raising your most profitable crop, which may result in loss of revenue for the individual farmer. The second thing that we see is that in some cases specialized equipment may be required for each of the crops that you grow, and so the more crops that you grow because you're in a rotation rather than a monoculture, then additional equipment has to be purchased, which can also impact the farmer's profitability. Another problem associated with crop rotation is that for us to get the most benefit from rotation, we need to be rotating for some distance. And because of that, you know, we don't have much distance in fixed tunnels that we can rotate. Obviously, where we have movable high tunnels, then we are able to rotate with a little more distance and likely get more benefit from rotation from those movable type structures than we do from the more common stationary structures that we see used in the state of Illinois. I'll give you some examples where the need for distance seems likely. If you read through the literature, you know, if you just rotate a little bit, you will see less Colorado potato beetle damage as long as you're not growing potatoes on the exact same spot where you were producing them. But to really see a appreciable and marked difference in the number of Colorado potato beetles, you're looking at rotating somewhere, and depending on the study, somewhere between 1/4 and 1/2 mile from the field where you last had potatoes in. Clearly, if we're dealing with a high tunnel structure that's 30 foot by 96 foot, and we're rotating within that tunnel or within a 120 by 200 foot garden out in the backyard, I think that you're not going to experience near the benefits that you would see when we were rotating from, you know, this side of a 40-acre field to the far side of the 40-acre field, where we were having a substantial distance in between the two areas where we were cropping. Again, you know, in this case here, where we've got these movable tunnels, I think that rotation likely is more beneficial because we've got multiple sites and we have some capacity to do things that simply are not options for individuals with stationary tunnels. And if you look, and there's lots of examples of this, these particular next two examples are from Four Seasons, which is one of the companies that manufactures movable high tunnels. But you can look here, we have a variety of different crops, and it's showing you where you would have your crop positioned at different times of the year, and what would be sitting fallow, or what kinds of crops you would be rotating in and out of as you move that tunnel throughout the season. Here's a different example, and in this particular rotation, they're only raising greens and tomatoes, but even though they're only rotating between those two crops, you can see that there are a lot of options for which one of the three spots the crop is sitting in, and how you're moving these tunnels to afford crop rotation and to get multiple uses out of a single tunnel. Again, that stuff is all very nice and I think does tend to work well, but most growers would have a tunnel. This is, again, the same picture. This is a tunnel from our place here. I think most growers are using fixed structures and don't have access to some of the combinations and opportunities that are afforded by a movable type structure. Another key thing when we think about limitations of crop rotation, in some cases we're growing perennial crops. This is a different high tunnel we work with at the station. This is one of the interns that worked with me last year. and you're looking at to her right, your left as you look at the slide, that's a raspberry planting, and we hope to have that raspberry crop fruiting for at least the next 5 years. This is the second year that it's been in the tunnel, and so clearly with perennial crops, crop rotation is not going to be our answer to disease control, but we still want good disease control, so we will rely on some mechanisms other than rotation to afford us successful production. And if you look, this is a slide that talks about, I think probably most of you have raised things in the field before, and there are some differences between management of disease in a high tunnel versus management of disease in a field environment. And if you look, this is a slide I borrowed from a presentation that was given by a gentleman from Purdue. But if you look, crop rotation, it talks about seeing pages 44 to 45 and ID 56. We're going to look at those in a little bit, and you'll better understand what that means. Fungicide applications are perhaps a bit more restricted in a high tunnel than they are in outdoor settings. And if we look at diseases that are caused by wind-borne phenomenon or insects that are wind-borne, there's probably little difference between field settings and high tunnels. And the reason for that is once you get into the main part of spring, those tunnels are going to sit with their sides open for most of the time, meaning that if there are insect or disease pests that are blowing by on the outside that would have attacked your field planting, there's a decent likelihood that they're also going to wind up inside of your high tunnel. Diseases that are dispersed by being splashed around, there is likely some benefit from being in a high tunnel environment because of the protection that is afforded from the high tunnel itself. If we look at leaf wetness, again, leaf wetness is one of the things that promotes disease development. Leaf wetness promotes disease development. We see that inside of a tunnel, we tend to have higher humidity, which can lead to greater leaf wetness in some cases, but that's a trade-off because it also doesn't rain inside of that high tunnel. So when we have prolonged rainy periods like in the summertime when a hurricane backs up and we wind up with 3 or 4 days of rain in a row, at that point the leaf wetness is actually better inside the high tunnel than out. This is the publication that was referred to in terms of talking about crop rotation and its benefit. This is the Midwest Vegetable Production Guide for Commercial Growers. And in it, it talks about this phenomenon of there are 3 kinds of soil-borne diseases that are very little impacted or unaffected by crop rotation. The first group of these diseases is caused by pathogens that are able to produce very resilient survival structures, and they can withstand very long periods of time without any host crop being present. Examples of these types of diseases is where crop rotation is likely of minimal impact would include things like fusarium wilt and root knot nematode. Jump twice. The second set of diseases that are likely not very much impacted by crop rotation are diseases that have a broad host range. They can survive indefinitely because they have so many different both crop or weed species that they are able to infect and continue to live on. These would include things like Sclerotinia, Rhizoctonia, and Verticillium. And the third group of diseases that are likely not much impacted would be those kinds of diseases that overwinter somewhere south of here and then are spread. Typically they'll ride, the spores of the diseases will actually ride on thunderstorm currents up out of the Gulf Coast states and be deposited into our fields here. And since the initial inoculum is not coming from anywhere local, then rotating doesn't have much impact on these kinds of diseases, and they would include things like sweet corn or sweet corn rust or downy mildew on crops like cucurbits. With all of that said, and I realize some of you are, many of you are new to high tunnels, but in the high tunnel environment, the kinds of diseases that we would most likely encounter would include, unfortunately, many of those that we just cited as crop rotation not being very efficacious in its ability to help control. They would be things like Rhizoctonia, Fusarium, Verticillium, and Phytophthora. And these are all things that are likely not very much impacted by crop rotation. But even though crop rotation may not be the best answer, there are lots of ways that we can successfully address those diseases. And so we're going to spend, I'm going to skip that. So we're going to spend, the rest of our time here today trying to get a better handle on diseases and how to help reduce their prevalence or their economic impact in our operation, particularly when we're producing inside of a high tunnel.
Jeff, we did get the link posted.
Okay, that sounds good. Yeah, for those of you, and that's good, she put up the one where it's free. I like that. For those of you that have not seen that guide, that commercial vegetable production guide, it's a co-op publication between several states. It's a very good publication, and if you are considering beginning a commercial vegetable enterprise, it is very good. It lists recommended varieties, it recommends fertilizer rates, it talks about what kind of disease and insect pests are likely to be problematic, and provides recommendations for the control of those insect and disease pests. It's all in all a really good publication. If you've not seen it before, you can click on the link that Deborah put there, and you can take a look at it as a PDF, which is downloadable for free. Certainly the price is right, and it's got information in it that is quite good. With all that said, let's go back. We're going to spend the rest of our time here today kind of doing a little bit of elementary plant pathology kinds of things, addressing disease. And the first thing we want to talk about is what has to happen for a plant to, yes, and the link does give you an option for ordering a hard copy. And those of you in Illinois, I think you can go to your local extension office and they will hook you up with information for ordering a hard copy as well. Some of the offices actually carry the publication and you can buy it while you're there. So what kinds of things are required for disease to be present? Well, there are three factors that must be present in order for us to have plant disease. Those three factors are illustrated as you see in this triangle right here. We have to have a susceptible host, we have to have a virulent pathogen, and we have to have the environmental conditions that are conducive for disease development. And this was known for decades and decades and was largely the model, and it has since switched and changed because we also have to include, it has to be the environment, pathogen, and plant all have to be the correct timing for disease to occur. For example, we may have a particular disease that causes a fruit rot, but we may manipulate our planting time so that when the pathogen is present is not the same time as when the fruit is present, so that the timing becomes off. During the course of the growing season, we may have had the right environmental conditions, we may have had the pathogen present, and we did have a susceptible host, but we had our timing such that the pathogen and the susceptibility of the plant material didn't overlap, and so the timing had changed. And so I think in modern times we normally look at disease as being a function of a pyramid rather than a triangle per se. And this is what we're going to spend, I think, our time talking about for the balance of our time together today, and that is, what are all of the different production practices that we might use that will make us have better disease control in high tunnel production? And here's a list of 10 of those things on the left. The first one is proper location of the high tunnels, the HTS, the high tunnel structure itself. Very quickly, that means that if you're south of Champaign in the state of Illinois, you have single bay high tunnels. They're going to be oriented in a north-south direction. As you get into northern Illinois, you'll actually orient your high tunnels to face in an east-west direction. And the reason for that is so that we accomplish the most warming early in the spring when the crop is growing. By having a warmer high tunnel, that allows us to do a better job of controlling humidity within the greenhouse. It also makes our plants that we are growing in there more vigorous, and vigorous plant material tends to be less impacted by disease than plant material that is struggling. So that's one aspect of proper location of your high tunnel is orientation. The second aspect of proper location of your high tunnel is that we want to have that structure so that it's got good drainage. We don't want to put a high tunnel in any kind of a swell or low area because we don't want water to ever run in onto the high tunnel. We want water to only run away from the high tunnel. So choose a location where you're going to have good drainage away from the tunnel and never have water actually running back into the tunnel. That water running in does two things. One, it floods the soil, which is not very conducive for plant growth, and secondly, it may well be carrying pathogens from outside to inside the structure, which is going to result in an increase in disease. Second thing that we're going to talk about for good management practices for disease control is maintain an environment that is most conducive for good plant growth and least conducive for pathogen development. Most common, I think, the best example for that would be do a good job of controlling the humidity within the greenhouse, and we'll show you some slides of that after a while. What about prevailing wind in considering orientation? Yeah, I mean, that's certainly a valid question, and that is certainly something that you need to consider is prevailing wind, and that is true whether or not you're using single bay tunnels or gutter connect tunnels, either one. We would normally have in Illinois, for the most part, have prevailing winds that come out of the southwest, and because they come sort of quarter to the house, in most cases, orientation in either north-south or east-west will afford some movement across the crop. But we would not want to align it southwest alignment from southwest to northeast because it would afford very little air movement. Was it north-south, south of Champaign, and east-west north of Champaign? Yeah, I don't want to use Champaign as the exact cutoff. If you'll go to hightunnel.org, as it's a website, you can look. They give you an exact parallel, and I don't remember which one it is, for a longitude location for where we do that switching. But I can tell you it's very near Champaign-Urbana as being the parallel at which point we start switching the orientation on those houses. Again, back to the prevailing wind real quick. We don't want to align that tunnel so that the long axis of the tunnel is laying parallel with the prevailing wind. We want to be able to get cross ventilation when we have the sides lowered. Number 3 was disease-resistant plants, which is obvious. I mean, if you've got a choice, we'd rather use disease resistance. We'll talk about that more in a bit. Disease-free transplant material or disease-free seeds, good growing conditions. Do a good job of scouting your tunnel on a daily or at least every other day basis. Do a good job and get on top of any pest problems that develop rather than waiting for the pest problem to become epidemic in its nature, where most of the plant material is already affected before you try to address the issue. And another thing we see is you need to have some skills at good diagnosis. If you think you have a fungal disease but you really have a bacterial disease, you misdiagnosed it. You would likely be using materials that were fungistatic in nature, and those materials don't do anything to control bacterial disease. So you can spray and spray and spray, and it's not going to make any difference. So proper diagnosis is another key for good management practices to control disease. That's true out in the field, and it's also true inside of a high tunnel. Management and appropriate use of chemicals. And I think number 9 is a very, very important one, and that is practice good sanitation. And we'll talk about that again. And if you look on the list, 10th of all the things that they list is rotation. And I think that That is because commonly rotation is likely the least commonly used of all of these things in a high tunnel environment.
Deborah just put a link up. Go ahead, Jeff. You're
Oh,
good.
okay.
It's the high tunnel link you were talking about.
Very good. Okay. In general, inside of a high tunnel, oh, I need to go back here. If you'll look at the diagram on the right-hand side of this, if you look, we've got our susceptible host inside of our high tunnel structure there. And we have some control of the environment, which remains outside of the tunnel, and at least in the very beginning, most of the pathogens should be outside the tunnel. Now, as you go into year 2, 3, and 4, some of that pathogen may be inside the tunnel as well, but you can see the very nature of the structure itself affords us some degree of protection, and in general, insect and disease problems tend to be less in high tunnels than they do in field production. But even though that is true, there are a few examples of things that tend to be more problematic in a high tunnel, and there's just a few, and I did want to go through those. One of them that is an absolute crisis should you develop a problem with it is leaf mold. We almost never see leaf mold as a problem of any significance out in field-grown tomatoes in the state of Illinois, but it can be absolutely disastrous in a high tunnel environment. Another example is timber rot of tomatoes, which we will commonly see outdoors, but it will impact only a very low percentage of the plant population in our field. In a high tunnel environment, we often see it colonizing and resulting in the death of a much higher percentage of the plants and having a much greater impact on our yield and profitability. Another example of a pest or disease problem that is more common in a high tunnel would be powdery mildew. Many crops that we would very seldom see powdery mildew problems on in the state of Illinois will in fact develop very significant powdery mildew problems in a high tunnel environment. Spider mites are another example of a pest that is greatly increased in terms of its likelihood that it's going to be a problem and likelihood that it's going to be a severe problem. Spider mites are very common in high tunnels, and because there's nothing to wash them off, there's less disease problems that typically would control many of the smaller spider mites as they were hatching. We have very high survival rate of the spider mite population, and they reach crisis levels very quickly. And my new least favorite pest in the entire world, at least this week, is thrips. And thrips can be much more problematic, again, in a high tunnel environment than they are outdoors, and it's much more likely you'll have to take some mechanism to address and control that pest. Okay, so we've talked a little bit about some of the generalities, and now I guess we're going to go through and try to get a little more specific on useful tools, either in addition to or in lieu of rotation, that we see growers utilize for successful high tunnel production. And before we start that, we've got to go back, and all of these different things that we're going to be talking about relate back to, in 1929, a gentleman named Wetzel developed 4 disease control principles that were exclusion, eradication, protection, and immunization. We don't use the same language as they did in 1929, so those have been updated. And now we talk about 5 principles. They are avoidance, exclusion, eradication, protection, resistance, and therapy. And I think for growers to be successful, we would like to we don't want to rely or put all of our eggs in one basket. We would like to utilize more than one of these principles and more than one of the strategies that you see outlined on the right-hand side of the principles in order to be successful. We normally will use a myriad of these things to give ourselves the greatest chance of successful production. Uh-oh, I messed up. And these are listed in alphabetical order, but they're not listed in the order that I want to talk about them. So we're going to go through, and as I go through each one of these, I will have highlighted in red. The first one that I would like to talk about of these six principles is therapy, and therapy means curing plants that are already infected. Two examples of therapy that are not overly uncommon. One of them is thermotherapy, which you're seeing in the bottom left, and the other would be therapy involving Meristem Culture, which you're seeing on the right. And I'm going to touch on these briefly. Thermotherapy is when we are going to take typically seed, although it can be other plant parts, but most commonly it's seed, and we are going to put it in a hot water bath, and the temperature in which we run the hot water bath and the length of time for which we keep the seed in that hot water bath varies from individual crop to individual crop. In other words, what we would do for tomatoes is different than what we would do for peppers. But the goal of this is that we're wanting to make the seed and all of the interior of the seed hot enough to kill disease organisms that are inside the seed, but not so hot as to actually kill the embryo itself. In case you're not aware of this, there are a number of bacterial diseases and viral diseases that are actually seed transmissible. So if we collect seed from a mother plant that has these bacterial or viral diseases, that bacteria or virus is already in the seed, and as soon as we plant it in the spring of the year, that plant is infected from the second it germinates. And so we can use thermotherapy to try to clean up that infection. Another example of therapy that we can do is called Meristem Culture, and that's where we go in and select a plant part. We may have a plant that has got viral or bacterial disease in it, but we go in through some manipulation and are able to select a part of the plant that is free of bacterial and viral diseases, and we may only take a very few cells. But once we have those very few cells, we put them into tissue culture, and by treating them with proper hormone regimes, we can turn around and grow back entire plants from those very few clean cells. So a common example would be we may start with a raspberry mother plant that's got some disease in it. We put it into tissue culture, we get the disease removed from it, and then all of the plants that we propagate off of that new clean plant that came from tissue culture, daughter plants are also going to be clean. So if, for example, you're going to raise raspberries in a high tunnel, because it's a high value crop and a high dollar piece of real estate, it may behoove you to go ahead and buy plants that are only one generation removed from tissue culture. And when you look in the catalog, you can actually order plants that are 1 or 2 generations removed for tissue culture, so that we know that we're starting with clean plant material. We don't really want to be beginning the whole cropping process off with dirty plant material. So that's all we're going to do about therapy for today. Next on the list that I would like to talk about is avoidance. And avoidance of the 6 principles refers to prevent disease by selecting a time of the year or a site where there is no inoculum. This would be an example of why we would like to use crop rotation. It's by moving to new sites all the time, we are getting onto sites where there is not inoculum. In addition to that, avoidance also includes planting in sites where the environment is not favorable for infection. And there's things we can do to modify the environment. We stated earlier that in general, the high tunnel has fewer disease problems than outdoors, and part of that is because we have a more controlled environment. It doesn't rain inside of the high tunnel. Leaf wetness tends to be less, although high relative humidities can become a problem. If you look in this picture, this is a high tunnel from a grower over in Union County. If you can look up in the ceiling of the greenhouse structure, he has small fans that are running, that are blowing air down on that crop. Those fans are circulating the air, helping to ensure that the foliage doesn't remain wet but dries off pretty quickly. And by keeping an environment so that the leaves don't remain wet, we reduce the likelihood for particularly foliar fungal diseases, but some other diseases as well. So that's a cultural practice, putting those fans in there, but it will help us by, it helps us because it is a mechanism of disease avoidance. We don't allow, or we avoid the disease from ever becoming a problem to start with. Another example of avoidance, and again we said that rotation has some difficulties with it. If you look here, these are hydroponic tomatoes. This is a different grower in Union County, but if you can look, his tomatoes are being grown hydroponically, and they are being grown inside that little bucket that you see, that tannish colored bucket, and the only thing that is inside of that bucket is vermiculite. That vermiculite is sterilized or replaced in between every crop, so that we are planting the crop into an area that is known to be free of pathogen. Let's see. Oh, yeah, we're talking about hydroponics. So in this case, we're avoiding it because we're only putting the plant material into clean growing conditions where pathogen is not present. So that's a little bit about avoidance. Exclusion is preventing the introduction, keeping the disease organisms from entering into your high tunnel environment. And exclusion is in large part practicing good sanitation. You know, you can, and we see this all the time, you know, the guy's out and he's tilling his residue out in last year's tomato field, and then he brings his tiller in and tills his high tunnel. Well, guess what? All of the disease organisms that were out in that field, you now have just potentially brought into your high tunnel. So before you take equipment into the high tunnel, let's clean it up. Soap and water is good. Bleach and water is better. Or other sterilizing agents like Green Shield or whatever, but let's practice good sanitation, and let's not introduce pest problems on our equipment. Additionally, if we're going to recycle, for example, planting containers like you see on the right-hand side, we need to sterilize them every spring or sanitize them every spring prior to using them. Again, bleach and water or Green Shield water or hydrogen peroxide water, there are several different choices, all of which will work. I don't care which mechanism you use, but let's keep it clean. Let's avoid introducing pathogens into the environment where we're trying to raise our plant material into this high tunnel. So that's a bit of exclusion. We're going to skip eradication for the moment, and we'll finish up our talk today visiting a little bit about eradication. Next, we're going to skip to protection, which is preventing infection by means of a toxicant or other barrier to infection. If you can remember, well, yeah, okay. If you remember back to the slide where we had the high tunnel, we showed that the host, our crop, was inside the tunnel, and outside of the tunnel was the pathogen. The very essence of a high tunnel, where you've got plastic protecting your crop, is, you know, it serves as a barrier to certain pathogens. And so the very essence of a high tunnel is one act of protection. But additionally to that kind of physical protection, we sometimes also use this to talk about chemical protection. And that could be the use of, for example, a fungicide, which helps to keep the plants from becoming diseased. Whether you're an organic producer or a conventional producer or somewhere in between the two, in some cases there are crops that you may well use a fungicidal material. There are definitely OMRI approved organic material registry index approved items that are fungistatic in their performance, and so we may use those, or conventionally we will also use fungicides. They will just likely be different fungicides than the ones that would be being used by organic producers. But in both cases, yeah, and Deborah just put up the list for OMRI approved materials, and the only example that I have in here, Deborah, is for fungicides per se, but there's also OMRI approved types of copper, for example, that are bacteriostatic in nature, and there are definitely insecticides that are on the OMRI list, Pyganic and Trust, and it's a long list, but there are still some of these protection chemicals that are going to be used or can be used to help ensure that we have profitable production and relatively low disease levels inside of our high tunnel. Okay, resistance. Utilize cultivars that are resistant or at least tolerant to infection, and do bear in mind that a couple of things that you need to understand. Resistance does not in fact mean immunity. Resistance is different than immunity. There are very few examples of immunity in the plant world. So you may have a resistant cultivar and still have disease. If we look at resistance, it's not an all or nothing case. We have typically a range from one variety may be highly resistant, one may be moderately resistant, one may be only slightly susceptible, which is the level down from moderately resistant, but there's this continuum for susceptibility or resistance to a particular plant disease. And so if you have a known problem, then we might want to select varieties that are resistant. Oftentimes, by selecting resistant varieties, we may be able to reduce our reliance on protective fungicides or bactericides that we talked about just a second ago in the protection section of this presentation. The one problem with resistant varieties is that sometimes there are occasions where a variety may in fact be very resistant to plant disease and even more resistant to sales. And I think most of you are probably raising this stuff to sell it, and in some cases, even though it has a great disease resistance package, for whatever reason, it may be that it results in, for example, tomatoes that don't have good color, or more commonly tomatoes that taste terrible. And if it's something that doesn't have good horticultural characteristics that you will be able to successfully market, then resistance may not be an option. So we would like to find varieties that both have a good resistance package and additionally offer good horticultural characteristics that fit well with our marketing regime that we're going to be utilizing.
Jeff, you want to catch that question there? What was the other sterilizing agent? You said bleach, peroxide, and what?
There's a product called Green Shield that's commonly used in, well, it's used in greenhouse industry and swine industry both, but it's a sterilizing agent that can be bought from greenhouse supply companies, and it's again mixed with water, very similar to what you would do with hydrogen peroxide or bleach. There's mixing directions on the label, and it does a nice job of disinfecting tools and equipment and clothing and those kinds of things.
Thank you.
If you look through the modern, through most seed catalogs, you're going to see beside the variety, and in this case I've chosen tomatoes that we're looking at. In the case of tomatoes, they're going to tell you whether the plant is an indeterminate or determinate, and then it's also going to give you some disease reaction codes. And if you'll look, for example, the first variety listed there, Atkinson, has disease resistance to F or N. If we go down to the bottom of this page, F refers to Fusarium wilt resistance to race 1, and N refers to nematode resistance. But you look, and there's several different diseases, and this will vary a bit from catalog to catalog in terms of what codes they include. But you look at different varieties, and by selecting different varieties, you get different level of disease resistance packages. So again, we would like to find a variety that has the horticultural characteristics that we require and the highest level of disease resistance that we can obtain. And the last thing that we're going to finish up with today is going to be eradication, which is eliminate, destroy, or inactivate inoculum or disease organisms once they have become present in your high tunnel. And we talk about these things because, for reasons that we had talked about earlier, sometimes rotation is not going to be our best option, and in the high tunnel much more so than out in the field setting, because it's such valuable real estate, because we've invested this money in the structure, we need to have successful production underneath of it. If it's not a tunnel that's designed to be moved, it is going to be very expensive and very labor intensive to move this structure to a new site. And so maybe we would consider using some method of eradication. Eradication, and there likely are other examples, but these are the ones that came to my mind. Eradication can include such different sorts of practices as solarization, the use of mustards, which release a compound called glucosinolate, which has activities that result in killing weed seeds as well as bacterial and fungal disease pests. Compost is a choice in some cases. And then lastly, we'll finish up talking about the use of hot water or steam for pasteurization of the soil inside of the high tunnel. So solarization, just kind of briefly, typically we're going to lay clear plastic on the ground. Clear plastic is it's hotter than black plastic or other types. It is the hottest type plastic. We put clear plastic and we allow the soil temperatures to increase to very high levels, and by doing so we hope to kill disease pests and also to kill weed seed. The problem with this, and we've done research with this here, it works fine. We can reduce the amount of Fusarium wilt in a watermelon planting, for example, by practicing the solarization. But the problem we get into is that it's not always overly consistent in the benefits that it provides. In other words, one year it may work very, very well, and the next year it may only work moderately well. And this inconsistency is a bit disconcerting to some horticulturalists. Another example, as you see in the upper left, is the use of mustards, which are grown as a cover crop. Once that cover crop has grown and it starts to flower, we will come in and chop the cover crop and then incorporate it into the soil. Through the process of chopping and incorporating, it releases a compound called glucosinolate, which is biostatic in its nature. It results in, like I said earlier, death of weed seed as well as fungal and bacterial organisms. The problem with this particular strategy is there are a couple that I'd like to visit about. One problem is that there's been a lot of research done on this mechanism, and if you look at the research, one time it works perfect. You couldn't have asked for anything better. We see less disease and perhaps insect, but less disease and weed pressure, and the crop growth and crop yield is greatly enhanced. Sometimes, though, we have too much glucosinolate that's formed, and the next problem with them is that it may work too well and cause carryover to the subsequent crop. And thirdly, in a high tunnel environment, it's not very easy to chop this stuff up and get it incorporated. We have large equipment to use outside, don't have access to it inside of the field. One of the products that is available that is showing pretty good result for, there are several guys that are starting to use this in high tunnels, is a pre-ground up, processed mustard leaf material, and it's sold under the name Biofence, and it tends to work pretty well. Compost is another thing that can be used, but we need to make sure that our compost was very well made. If our compost was not maintained with proper temperatures for proper periods of time, we may actually result in importing more pathogens. If we do have very well made compost, however, there has been a lot of research done in North Carolina looking at this, and compost tends to work well as a mechanism for reducing disease inoculum in the soil, and also actually serves sometimes as a weed control agent. Lastly, I want to talk about steam, and we're about out of time, so I'm just going to go over through this part very, very quickly. But steam can be used. It was widely used. Here's a project that we did at the station. There's our steam generator, and we basically came in and inoculated beds with disease, came back and steamed those beds, planted crop into them, and looked at the impact that steaming has. When we steam soil, we're really pasteurizing it, not sterilizing it. We hold it at 160 degrees for an hour, and we still retain some of the beneficial microbes. We don't annihilate everything present in the soil, but we do hold it at a high enough temperature to get rid of plant pathogenic fungi and bacteria, as well as weed seed. In terms of its efficacy, we should get some slides here showing you it does a great job for weed control. If you'll look, there's lots of hand weeding where we don't. In fact, what we find is that what it costs for the diesel fuel and the labor to steam is more than overcome by what it costs for hand weeding labor. It's probably actually cheaper to steam than to not steam, because the amount of time spent hand weeding goes to pretty much zero. Here's a nice example of, how effective is it. You can pretty much tell, I think, without me telling you, which part of those beds was steamed and which part was not. In terms of the results, we've got better yields off of steamed versus not steamed, and that was true even in cases where we didn't have very much disease development. Just the process of steaming shifted the soil flora and fauna that it benefited crop production, and we had increased yields even in the absence of disease. With that, I think I've talked for almost the whole time, so I'm going to try to go back up through here and catch up on some of these questions.
Yeah, I think we need to go back up here, Jeff, to, let me see here. We got the green shield. Okay, solarization, Carrie A. Is there any effect on beneficials in the soil when you do solarization?
Again, I think that we do try to monitor the length of period of time for which we keep the soil, I guess, cooking, for lack of a better word. But I do think that's one of the problems with solarization, is that it's so dependent on things like ambient temperature and the amount of solar radiation that is being received during the period of time that you're doing solarization, that it is likely a little less consistent than something like steam pasteurization, which I think has a little more predictable result. And it may well be that part of the time we wind up hurting quite a bit of the beneficial to a greater extent than we wanted to. But the theory behind solarization is that it should be manageable to the point where, in fact, we do leave part of the good soil microbes in place.
Okay, and then the next one on rotating for annuals within the tunnel.
Yeah, and I think, I'm not sure what they're after, but I guess my questionary thing is this, is if I move my tomatoes from the bed over here on this side of the high tunnel this year to the bed on the other side of the high tunnel the next year, and for example, my concern is tomato leaf mold, I really don't think I'm going to get very much benefit from that rotation. So I think that's why we spent some time talking about these other strategies or mechanisms for achieving good disease control. I also
Jeff,
have
that question does bring up a good point that, if you're, and we have a lot of new high tunnel people on here, planning for these rotations is really kind of you really got to do your homework and sit down and map it out, and you don't do it just kind of, flying by the seat of your pants. You usually put a rotation together probably actually for a couple of years, and then you got to think back to, well, I'm actually going to have, 3 different crops of lettuce and what have you. So it sounds like, it's something you just do, but it takes a lot of homework, doesn't it?
Yeah, absolutely, and I do think that, to me it makes it is a much better or more important phenomenon where we have these multi-position movable tunnels than what we're, I think it's going to have a lot greater benefit there than what we're going to see in, again, the vastly more common tunnels that are in a single position.
Do you want to catch that one from Beth on solarization?
Let me see if I can find it.
How long do you typically apply the plastic and at what temperature?
Yeah, it depends. In the case of our research that we did here, we left the clear plastic in, and we were working with watermelon. And we left the clear plastic in place all the time, and the reason for that is, first of all, watermelon is very tolerant of very warm temperatures, and secondly, as that watermelon grew, at some point it starts to shade out, and we start losing that heating effect, and it kind of was a self-quenching system. Once the plants got growing, then they resulted in it sort of shutting itself down because of the shade that was afforded by the leaf cover. I think that depends in terms of the length of period of time that you're going to use this. I think as you read through studies that have been done, there is not total agreement amongst the experts as to what is the ideal length of period of time. And part of that is because, for example, if you read through that Minnesota manual that was part of this presentation that we gave today, they would state that they likely never achieve warm enough soil temperatures to feel that they get much benefit out of solarization. So the problem with solarization is that its results are pretty inconsistent.
And that question from Sherry there about common diseases in the location. It'll be kind of specific for your area, but Jeff, you want to cover, 9 out of 10 high tunnel growers are going to have issues with, A, B, and
right.
C. You could
right, and when we go back to those are going to be, unfortunately, we had a list of types of plant diseases that are not very well addressed with crop rotation, and unfortunately a lot of what we're going to encounter in tunnels in Illinois were pathogens or diseases that were on that list. Those would have included things like Rhizoctonia, Fusarium, Verticillium. They're things that are pretty commonplace. Now, many of those, Verticillium for example, and Fusarium, can be overcome with genetic resistance, and so we can take care of it there. Problems that you commonly see outside in Illinois on tomatoes, things like early blight and septoria leaf spot. These are often really not very big problems in the high tunnel. If we have sited the high tunnel in a spot where water's not running in, we have a good selection, a good site selection so that water runs away from the tunnel. We've done a good job managing our irrigation, and we have fans in place and manage our ventilation such that we don't have these extended periods of time where leaves remain wet. And so we wind up actually seeing those diseases in many cases going to absolutely zero with no fungicide application being required whatsoever.
Yeah, and James just put up that Vegetable MD link for Cornell. That's a really great one.
Yeah, it is. Yeah, it is. And that Cornell WebMD link also has a tremendous, and I tried to steal it and put it on here, but it was just way too big of a chart. But they have a great chart listing all the tomato varieties and a lot of different diseases and their reaction in terms of whether or not they are very resistant, moderately resistant, or moderately susceptible. I mean, it's a great chart that has a ton of tomato varieties listed on it. Well, excellent. Looks like I confused everybody sufficiently to where there are no questions.
Hope to see you all on next week, Jeff. I'm going to have you hang on here for a little bit, and but everyone else, if you want to log off, you can do that, and hopefully we'll see you next week.